Okay, so here's the second part of our energy lecture. This is more talking about energy conservations and energy conversions and a little more information about different types of energy. So we've looked at our two major types of energy. We have potential energy, energy of position or stored energy, and we have energy of motion. And we're going to take a look at some other forms of energy that are around these basic types. And we're actually going to add another type of energy in here as well. Before we talk about that, we want to talk about something called the law of conservation of energy. Now, this is a scientific law. It is been noticed so much in nature that we seem to believe that it is true, and it's never been disproven that it isn't true, so it's assumed to be true at this point. So just how we have a law of conservation of matter. Matter cannot be created or destroyed. It can only be rearranged. That's what we talk about when we talk about chemical equations. We're talking about the law of conservation of energy. Energy cannot be created or destroyed. It can only be transferred from one place to another or transformed into from one type of energy into another. So we're not creating or destroying energy. We're either sending it out someplace different or we're changing it into a new and different type of energy. So the law of conservation of energy deals with one of those executive pendulums. You know what those are? Those things that sit on your desk that have the little steel balls on them and with the little strings, and you start the ball on one side and it hits all the balls, and then the other one on the very end swings off, right? And so when one ball hits another, it's transferring the energy. The one has energy of motion and it stops, and it transfers its energy through the balls and is the ball in the end. Now, according to the law of conservation of energy, that motion should continue forever and ever, but it doesn't. Eventually, the motion stops, okay? And the reason that the motion stops is because it's transforming into new different types of energy. You hear a little click, click, click. So I'm changing from mechanical energy, energy of motion, into a sound. And if you were to feel those steel balls, you would feel that they're a little bit warm. There is some transformation into heat. So what we're saying, remember, with the law of conservation of energy is energy cannot be created or destroyed. It may transfer or change, but the total amount of energy never changes. So we looked at some types of energy already. We've already looked at potential energy and kinetic energy, but another type of energy that we haven't really discussed is matter or mass. Remember how we were talking about the fact that there are two kinds of things in the universe. There's matter and then there's energy. Well, some scientists believe that matter is simply another form of energy. So one of those scientists was Albert Einstein, and he believed that with his famous equation, E equals mc squared, right? Everyone knows that Einstein came up with this great equation, E equals mc squared. But when you ask people, well, what does E equals mc squared mean? Nobody knows. They might say, oh, energy is equal to mass times the speed of light squared. That's great. What does that mean? Okay? And basically, what Einstein was saying in this equation is that matter is simply another form of energy, and that energy can be converted into matter, and matter can be converted into energy. Now, we fully realized this concept when we looked at fission and fusion reactions. Do you remember that in Unit 2? When we would have a fission reaction and we would say some of that matter would change into energy. Do you remember that? And this is Einstein's equation was actually discussing that. So let's take a look at potential energy, different forms of potential energy. We said the gravitational potential energy due to position or height above the earth, and work that gravity could do if you could just get the object into motion, right? So here at the very top of a waterfall, the water has the potential to do a lot of work if I could just get it moving. As it moves down the waterfall, I can convert that potential energy into kinetic energy, and I can transform that into different types of energy. Okay, so as we were talking, we said one type of potential energy is gravitational potential energy. We've already talked about that. But all other forms of energy, there are five major forms: mechanical, electrical, thermal, nuclear, chemical. So electrical potential energy would be something like a battery. This has the potential to do work. All I have to do is to hook it up, right? So I could get the electrons flowing. Chemical potential energy, the fuel that you put into your car before you burn it and you convert that to mechanical energy, or the food that you eat. This is stored potential energy until your body breaks it down and converts it to the energy of your metabolism. And even elastic potential energy, if I pull back on a rubber band, if I took a rubber band and I pulled it back so that I was holding it right in front of your face, that would make you very uncomfortable because there's stored energy there. If I just let the rubber band go, it would have the ability to do some work, cause a little sting even. Okay, so elastic potential energy is a form of potential energy. Nuclear potential energy, radioactive elements have the potential to undergo fission or fusion or even radioactively decay and release energy. So kinetic energy also comes in many different forms, right? Energy of motion comes in many different forms, not just stored energy. So some of the basic motion would be like linear motion. A car driving down the road, motion in straight lines, has kinetic energy, simple kinetic energy. This airplane flying along, for example. We have rotational kinetic energy, spinning and rotating objects. The Earth has energy because it's spinning, and that energy is causing wind patterns and weather patterns and all kinds of things. We have vibrational energy, motion due to friction or heat. And heat is actually the internal motion of particles. Your little particles are moving. How fast they're moving is how much heat that you have. So if you're just have just enough energy to vibrate in place, you're a solid. If we add a little more energy to that, usually in the form of heat, right, we can create more motion. Okay, so vibrational energy is a type of energy. Okay, another type of motion is wave motion. So, a couple of things, some energy moves in the form of a wave. For example, electromagnetic radiation, like light energy or heat energy, will sometimes move out like a wave. So, the sun's light and heat is reaching us through space by traveling as a wave. Um, when you're at the shore and you see the waves of water, what's really happening is that energy is traveling through the water and disrupting the water. And that's why earthquakes cause these huge tsunamis, right? Because it's a lot of energy that got released and is now traveling through the water. Sound is a form of wave energy. And actually, what's happening is that the wave hits the um, eardrum, travels into your ear, taps on your eardrum, and then the eardrum taps against the bones in your ear, and the bones in your ear tap against the nerve, the auditory nerve, and then that sends a message to your brain and you perceive that as sound. So sound is a form of mechanical energy in the form of a wave. Electricity is a moving electric charge. That's a form of kinetic energy. When electricity is traveling through a wire and is used to run appliances and things, that is kinetic electrical energy. We already talked about the idea that heat is your motion, how the particles of matter or how fast they're moving, and that's what we perceive as heat. So thermal energy is the moving of your atoms, and how quickly they're moving determine how much temperature that matter has. And so those are all different um, forms of energy, the three major types of energy. We talked the last time in the last note section about kinetic and potential energy. We're adding to that matter now as another form of energy, thanks to Einstein's equation, E equals mc squared. But then potential kinetic energy especially can come in 5 other forms: nuclear, heat, mechanical, electromagnetic, and thermal.